Yeah, it should be live now. So again, just to reiterate, let's quickly recap. These are the list of recipes that you can deploy, and each of these recipes can set up these particular tools for you. So you can browse through the list and check if all of the tools that you use are already covered in one of the other recipes. But now the question comes that if your recipe is not covered here, for example, if you want something like Kubeflow along with, say, Selden, that is not covered in any of the recipes so far. So what do you do? So in that scenario, what you can do is you can extend existing recipes. So in this demo, I'll be showcasing how exactly that you can do that and how easy it is to do it. So for that, let me jump into the code. This is a repository I have on my local VS Code. I'll just zoom in a bit so that everything is visible. Is that clear? I think that solves it. Now, the first step that comes to your mind when designing any recipe is to select what base recipes you're going to use. So for example, let's start with one recipe that we're going to do today is AWS-Kubeflow Selden. So that will be maybe a combination of AWS-Kubeflow Kserve and some recipe which has Selden. So we know that AWS Minimal has the Selden, what you call module here, and it also has a Selden file which corresponds to the Selden deployment. So now I have some idea that maybe this new recipe needs to be a combination of AWS-Kubeflow Kserve and AWS Minimal, right? So what I'll do is I'll choose either one of these as the base recipe. So maybe I'll just copy this entire recipe section. I'll paste it here. So this is supposed to be my new recipe. So I'll call this AWS-Kubeflow Selden. All right, so this is the new recipe, and inside this recipe, I'll see there are multiple modules and files. So I don't need Kserve. I need to replace it with Selden. So that is one of the first things I'll do. So I'll go into the AWS Minimal recipe. I'll see there's a Selden module situated here. So I'll just copy this Selden directory. I'll go into this one. I'll delete the Kserve, and I'll just paste the Selden. So this transfers the module from the other recipe. And now I have to maybe switch the file which describes or which implements this particular module. So basically, you have two types of resources. You have modules and you have files. So the modules are basically a set of files put together. And these files just call these modules to implement the particular resource. So I just went into the Selden file, and this Selden files look like this. So maybe I'll just copy this, I'll just copy this entire file, or maybe I'll just do it from here itself. And I'll just paste it in the new recipe, right? Let me do that. And I'll remove the Kserve file because it's not relevant anymore, and there's no Kserve module anymore here. That's it. So on the outset, this is exactly what you need to do. And since we are moving between only AWS recipes, we don't have to actually configure any of the parameters, but we'll still go into this new file and see if there are any missing parameters or links or not. So inside the Selden file, you can see what it depends on. It depends on the EKS module, which makes sense because EKS module is the module which sets up the cluster, and Selden is going to be run on the cluster. So it depends on module.eks. We'll just make sure that EKS exists in this particular file as well. It does exist. So there it is. And usually when you're moving between recipes that are from different clouds, for example, between, say, AWS and GCP, you'll have to modify these elements there. So in the case of, for example, let me just showcase to you how the Selden file looks like in the GCP module. So if I go into the GCP recipe, it here looks like depends on Google Container Cluster GKE. That's it. So when you're transferring between files that are from different clouds, you have to make sure that you modify these cloud-specific bits. And this is pretty simple as well because you can take reference from many of the existing recipes. For example, I know that this should be module.eks because I have seen other recipes which are built on AWS. Right? So that's also pretty simple to do. So in this case, it's even simpler because you don't have to modify even these values. So I just go through this once and see if there's something that needs some modification. All right, so this makes sense. So I have a local file. So basically, a local file is something that you use to configure all your resources. So in any recipe, if you go into the locals.tf file, you'll find a list of parameters that you can configure. And each of these parameters correspond to some of the other resource. For example, if you want to modify the name of the S3 bucket, I'm going to change this value without going anywhere in the Terraform file. So if you're not familiar with Terraform, if you don't want to get involved with Terraform files, you don't have to worry about that. You just come to the locals file and just modify some parameters here, right? So going back to the Selden file, I can see it references a Selden parameter in local, which doesn't exist as of yet because our base recipe was built on the Kserve stuff. So I'll go into the locals file. I'll locate the Kserve block. So then there should be a Kserve block. There it is. I'll get rid of this because there's no longer a Kserve element here. And to substitute the Selden block here, I don't have to rewrite any elements myself. I can just copy paste again from the AWS Minimal. So I'll just go to the AWS Minimal locals.tf. I'll locate the Selden block here, and I'll just copy this entire thing. And now I can go back to this one, and then maybe I'll just paste it here. That simple. So this is one of the steps we did. Now let's go back to this file. So we have covered this one. We have looked at the locals file, and this seems to be fine as well because it again depends on the EKS cluster. So don't have to worry about any of these things. And this is again cloud agnostic. This is just Kubernetes namespace. So this file looks pretty sorted for me. And I'll just observe there's something that needs to be modified. For example, let's say EKS is already the same Kubeflow, we need that, and Selden also we need it. And the other thing that we need to modify is the variables file. So locals is the part where you configure any non-secret or non-secure parameters. For example, you configure the EKS name, you cluster version, all that stuff. But for variables which are really sensitive, for example, your artifact store key and all those things are part of the variable section. So you have to also browse this section to see if any of the new elements that you have put in have any relevant variables. So for that, what I'll do is I'll go back into the AWS minimal recipe from where the Selden came from. I'll go into the variables file, and I'll check if there's any Selden specific variables that I need to put into the new recipe. So all of this looks like the MLflow tracking server variable, so I don't need to worry about that one. This is the cloud SQL metadata store, doesn't need to worry about that. And this is just the stack configuration. So none of this actually relates to Selden at all. So the new variables file in the new recipe doesn't need to have any Selden stuff here as well. And this values.tfjars.json file is just what values you use for each of these variables. Right? So this also again corresponds to the same variables file and doesn't have any Selden elements. So again, this is really simple for us since you don't have to modify any of these. But in the event that you have something to do with the MLflow server, you'll have to modify this in terms of the cloud that you're using. For example, if you're using GCS or GCP, you'll have to modify these variables with the name of the GCP variables. And that is also pretty simple because you can just reference any GCP recipe. For example, I'll just go into the GCP minimal recipe. I'll go into the variables, and there you go. You have all the variables for the Cloud SQL or MLflow specific use cases. So that's also pretty simple, but we'll come back to the recipe at hand. So, all right, so we have transferred Selden. We have modified the Selden file. We have chosen values for locals, which makes sense. And we have seen that variables doesn't have any of the outputs related to Selden. Now what we need to do is change the output file. This output file.tf is the file that gets generated at the end of the recipe creation. And this file, if you look at it closely, is the stack YAML file. So this is the file which ZenML imports as your ZenML stack. So it's very obvious that we need to modify this file to change the reference to the kserv from kserv to Selden. So I'll just quickly go through this file and observe what are the changes that we need to do. For example, let's say artifact store doesn't need to be modified because it's still the same. So maybe I'll just scroll down and I'll see that if there's some of the component that we need to modify, and very obviously it's the model deployer. So right now it's kserv as the flavor, and this is because the recipe derives from the Kubeflow kserv recipe. So I'll change that to Selden. And if you're not familiar with what variables or what values to use here, again, you can reference the output file of the minimal recipe. So I'll just close this one here. And if I scroll down, you can see it's still the same. So I can just copy this entire block from the minimal recipe. There you go. And I'll just paste it here. After pasting, I'll see if there's some modification I need to make, which is specific to this recipe. So there you go. I've pasted it. Now I'll just remove this one. And let's just go through this to see if there's any wrong values that are here. So flavor is Selden, makes sense. You can change the name of this if you want, depending on the new recipe context. If you are developing something new, you can change the name of this. Context doesn't need to be modified because it comes from the EKS cluster. Namespace, again, doesn't need to be modified. Base URL. Now, this is something interesting. It comes from a Kubernetes service data point. So basically in Terraform, this data means data point. So this is where you get information from. And it is referencing a service called Selden Ingress. Now we'll have to make sure that this service exists in this particular recipe as well. So there's a file called get URIs. Now this file is responsible for fetching all the URIs for your service. So for example, the MLflow tracking URL. So whenever you deploy a recipe, you get the MLflow URL, you get the Selden URL. All of those URLs come from this file. So it basically fetches the Kubernetes service and then goes into the spec of them and pulls the particular URL out. So here you have to modify this from the kserv thing to again to the Selden stuff. Again, pretty simple. Don't need to write a piece of code. You just go to the AWS minimal recipe, find the get URI file, bring it here. I'll just replace the kserv block with the Selden ingress. So what I'll do is I'll just do this one. I'm sorry. Yeah, there you go. Copy this thing and paste. That's all. So I'll just, again, after pasting, I always have to verify if it still makes sense or not. So let's see, Selden ingress, and all of this stuff depends on module.selden. So we'll just make sure that Selden module exists here. So I'll just scroll down, check, Selden appears here. So nothing to worry about here again. So get URI is also sorted. Now I'll go back to the output file which you were editing. So all of these parameters are covered. We looked at the base URL, which now has the right URL services as well. So just don't need to worry about any of the rest of the stuff. The secret, again, you can change the name of the secret if you want, but this is not relevant because secret is something you create after you registered your stack. So this can be any name you want. Secrets can be whatever name you please it to be. And then you also change the name of the stack file. So I just rename this stack file to maybe Selden or something like that, which reflects what this name is. Basically, that's all. All right, so now we have modified the output file. We have modified the locals and the variables. What we also need to do is modify the outputs. Like, this is not really relevant in the context of ZenML execution because ZenML, the stack CLI commands only worry about the output file, and this is the only stuff you need for actually registering a stack. But outputs are also necessary for you to debug or get any passwords and other kind of values here. So for that to happen, you also have to modify the outputs to reflect what the new recipe does. So naturally, this output will have something to do with kserve. So we're going to replace the kserve stuff with the Selden stuff here as well. So let me scroll down a bit. Each of these output blocks have some comment which tell what stack component it's relevant to. So container history, ML tracking server, kserve model deployer. So here it is. So these two outputs correspond to the kserve model deployer. So again, like we did with the other steps, I'll just remove this here. And for the Selden thing, I'll just copy from the AWS minimal file. I'll just bring it here. I'll remove this file here. And then I'll scroll down to where where Selden is. So you can see this block corresponds to the Selden model deployer. So again, I'll just copy this entire block. I'll paste it here. That's all. And again, after pasting, let's just verify once that all of this makes sense. So it references the Kubernetes namespace called Selden workloads. And this should be inside the Selden file. It's there, makes sense. And then it references the module Selden, which is also there. We looked at it, and references the Kubernetes service, which is also present right now. So output's also complete. So these are the only files that you need to modify. So there's a checklist. You first reference, first decide what recipes to use. So what base recipes you need. Then you reference, then you just transfer files that you need from the existing recipe to your new recipe. You modify any locals parameters. You modify any variables that are required. Then the output file, which is required for ZenML to create the stack, and then the outputs, right? So these are the steps you need. You also have to modify the README, but that is just for the sake of getting other people to know what this recipe looks like. And that's all. So basically, these are the steps. And just to make sure tests pass on the repository, you also have to do a Terraform format. So this will, we're not in the right directory. I'll just quickly go into the AWS-Kubeflow Selden directory. And here you can do Terraform format. This is going to format any files and see if there's any, no problem so far, because we just did copy paste, we didn't try to encode at all. And then you can also do Terraform apply, just to see if there are any syntax errors, sorry. Because sometimes when you're transferring files, there can be something which is going wrong. Okay, so what should do Terraform init? I think we didn't init yet. So init will download all the modules providers and then we can do apply. So far, any questions? Because like the meat of the project is already done. So if you have any questions, let me know. We'll be happy to answer. Like, that's how simple it is. Like there might be some bugs here and there, but that'll be all be clear when you do Terraform apply. Hamza?
Yeah, I mean, this is really cool. I've never seen you actually do this live. So you literally just copy pasted different recipes and mixed and matched the modules. Isn't it great if we would be able to do this automatically in the future? Like if it's just copy pasting stuff, then ZenML should presumably be component level aware. And if you want Selden with MLflow with, I don't know, on S3 on Kubernetes, you should be able to maybe select it through ZenML. And in the back, we could mix match these Terraform modules.
Yeah, that's a wonderful idea. Like we've been working on, I have a design in mind which does exactly that. So in the future, we might have the user just provide a file to us, like we want this orchestrator, this model deployer, and all of those stuff. After this configuration is provided to ZenML, ZenML can then in the background do what I just did. Like I just said, automate this copy pasting of stuff. So you can just mix these modules together into a recipe. So you'll have some kind of a dynamic recipes that get built every time you supply a configuration file. And then when you just do apply, it applies this thing. So yeah, definitely that's something which is in the works, like not in the works, but in the plans. And
Yeah.
hopefully we get the working part.
Yeah,
So,
that
but that's
sounds so
yeah.
interesting.
Sorry.
And I think like Karndeep has a question. Can you share any link to implement ZenML step by step so that I can directly use it on my use case? Maybe and like Karndeep, there's many parts of ZenML. So today we're looking at stack recipes. Which part of ZenML would you like links to?
Do you want to see how pipeline runs and stuff like that? Also, while this is installing, I'll maybe just go over another point that like what we did right now was pretty simple because it was just between AWS. But like we also have a video that that is how the AWS-Kubeflow Kesa recipe got born. So essentially, this recipe was also recorded as a video while I was building it. So you can see how I went from GCP Kubeflow Kserve and using AWS Minimal to have AWS Kubeflow Kserve. So that's also something that we'll publish after we are done with this session. So you can also have a look between how transferring files between different clouds look like.
Yeah, hi Jayesh and Hamza. This is Karan here. It's great to see the implementation of ZenML and what the problem it is solving right now. And because I have been using a lot of tools and we face a lot of issues while adding up these components and tools in pipeline. And we found this ZenML to be very interesting tool to use in our use cases. And I generally work in a e-commerce domain and we are looking forward to use a simple tool that can do all of the things for us in terms of machine learning progress. So I started looking onto this ZenML and found it very interesting and trying to look out for my use cases. So we have so in e-commerce we have a lot of use cases in terms of image analysis, monitoring of detection, even in terms of market basket analysis. So a lot of use cases are coming up in e-commerce, and we wanted to use this ZenML. So I just wanted to understand I just wanted to understand the flow of the ZenML with respect to the use cases, and so that I can implement it on any of the use cases that I'm looking for in future, and I can add it up to the stack for the e-commerce and can use it very easily. I can see this tutorials on your YouTube channels. Even I follow Jay also on YouTube. I have seen his videos. It was quite interesting to watch those things. But I found some little gap on understanding how to utilize this things particularly. So if you can guide me, maybe I can go through those step-by-step approaches to use the ZenML and properly get into the use case development, and maybe I can also contribute to the community once I have done those things.
Yeah, that's nice. Like maybe we have some links like ZenBytes, and if you go into the documentation page on the left, you'll have a list of examples that you can follow. Like the ZenBytes are there. You also have ZenML
Right.
Go that helps you run a quick start. So maybe you can
Right.
reference those examples. If you are stuck, then you can contact us on Slack. We have really active community there. We're sure we can help you out
Okay.
there. So
Okay,
yeah,
Jayesh, yeah.
so we
Understood.
just missed this. So I think Terraform Apply ran successfully because it showed you the entire list of things and it has 78 resources to add. So that's it. The recipe is now complete. So it's that simple
Right.
to implement a new recipe, and you can choose whatever elements you want. We always welcome any new contributions. So if you want, say for example, in the future, if you have something like I'm not sure, like just pick any elements you want and then try to mix and match between those things. And if you
Right.
face any problems, we're here on Slack to help you out. So that's
Sure.
the basic idea between this. And apart from that, I think there's not much to present, but there's still a lot of work that recipe is going to be there's going to happen in recipe. For example, we looked at a lot
Right.
of tools that people use, like Ventoml and other stuff. Like we don't have that yet. So if you have an idea to implement those as part of new recipes, as entirely new
Okay.
modules,
Okay.
please feel free to do it. on the repository.
Sure. Yeah. Thanks, yes. Thanks yes, for that answer. I will look onto documentation, although I was referring to it, but I had some gaps. Like I didn't understood this recipe earlier. Like when I was referring to the documentation, I was not able to understand why this recipe is there, why we have different recipe like AWS minimal. What is this about, and what is that AWS Kubernetes recipe is about? So now I understood. Like these have different things, and the all sorted recipe has been created for us. We just have to configure it according to our use case.
Yeah, so
So
maybe I can link the documentation page where there are commands on how to run this. So you don't have to run
right,
Terraform apply, Terraform init. You can just do ZenML stack recipe deploy. So that has some
right.
other goodies involved, like more logging, some help with
Mhm.
the error messages on how to debug different situations. So all of that can be found in this
Right.
documentation page. Thank you, Hamza, for posting it. So you maybe take a look at
Yeah.
that. And it's
Yeah.
constantly being evolved. We add new features with every release on the stack recipe CLI. And again, contributions and ideas welcome.
Sure. Thanks, Jayesh. Thanks, Hamza, for the link sharing. Thanks.
Awesome. I mean, we're out of time, but if the community just wants to hang out for a second, I think we didn't get too many questions about the demo itself, so I'll just maybe